Okay, so graphing trigonometric functions, right? Firstly, we'll try to understand sine inverse function. Y is equal to sine inverse function. So we'll discuss about sine inverse function here. Now, we know from composite functions in math methods, sine inverse x. Sine inverse sine x is equal to x, right? So when you have something like this, sine theta is equal to half, then you need to find theta. So what you did, you introduce sine inverse in both sides. Like this. You introduce sine inverse in both sides. And then you put this here. Because sine theta is equal to half, right? So sine theta is half. So that is what is given here. So now, according to our definition, sine inverse sine theta is going to be theta. And that would be sine inverse half. This is how you actually get it using composite functions, inverse functions, right? Right. Now, let's look at it in this way. So you have y is equal to sine theta, right? Then, if you really look into this theta is angle. This y is a value. So what this sine function is doing, sine function is converting an angle to a value. Converting an angle to a value. That's what the sine function is doing. Right? Good. Now let's look into the inverse, right? Sine inverse. So in here, there is a value. You get the angle here. Okay? Very important to understand. Right. See, you put a value here. Output is angle. Right? So this you have to understand. Now, we'll try to understand more. Okay. Consider y is equal to sine theta. So the maximum value of y is -1 to 1. That we know that range. Right. So what about the theta? Theta is going from 0 to 2 pi, right? 0 to 2 pi. That's your period. Right? So if you visualize it, it's a simple thing. It looks like this. 1 to minus 1, 0 to 2 pi. Right? Now, 0 to 2 pi. Right? Now you can generalize it if you want, right? So you can further go from here and here. So you can generalize it more if you want. And if you want to generalize it, right, for both of them, you can add 2 pi k, right? And you can extend the period, right? So that's fine. Now, let's think about the sine inverse case. So if you do sine inverse, and that is sine inverse y is equal to theta. Now, domain range are changing, right? Swapping. So now the domain for sine inverse here is going to be minus 1 to 1, right? Minus 1 to 1. Right? So this one is going to be now other way around. So what I'm saying as example, if you have y is equal to sine inverse x, this is inside, right? So it's like sine inverse, you get inside here. So what I'm saying, this guy is between 1 and minus 1. So inside is between 1 and minus 1. That's what I'm saying. So if you have a question like this, y is equal to sine inverse 2x minus 1 or something like that, right? So that is the inside part. Inside part is 2x minus 1. So you can say 2x minus 1, this. You can straight away write this one. So this is what we need really. Okay. So how do you look into it? You can understand y is equal to sine theta from domain and range, then inverse of it, and then domain and range is flipped. So logically, you have to keep it with you. Memorization wouldn't work here. So how many things to memorize? Keep your memory for biology. Right. Now, plotting. Now, when we plot, okay, sine. We'll do it carefully. Right. So it's something like this. Right. So this is going to be pi divided by 2. This is a little. So I will properly do that. Yeah, something like that. This is going to be pi divided by 2. This is going to be minus pi divided by 2. Right. So this is going to be 1 here. This is going to be minus 1. So this is our sine curve. Sine x curve. Like this. Now, how your inverse function looks like. Let's think about this. How your inverse function looks like. Something like this. Okay. Something like this. So I'll show you the proper thing in a minute. So there, this guy would be pi divided by 2. This guy should be 1. Right? So this guy should be minus 1. This guy should be minus pi divided by 2. Domain range swap each other, right? That we know. And also when we have a line like this, inverse functions are symmetric about y is equal to x, right? So those things are there. So that's why you get this little part here. Okay. Right. So we need to pay attention. No memory to here. Right. So you can see that this guy is changed. Right. This guy is changed to here. Swapping, you can see the swapping properly. Right. And you can see this guy is swapped here. And you can see this guy is swapped here. See? You can see the swapping. Right? So that means dom of f is equal to ran of f inverse, that concept. Ran of f is equal to dom of f inverse, that concept. Okay. Yeah, so that's all you have to know about the sine inverse functions. Right? Okay, let's go to our note. Look at this. I explained everything. Sine function and how inverse function looks like, see? Right? So this one I explained to you, goes from here to here. Right? Then this one I explained to you, it goes from here to here. And y is equal to x. See, I explained that to you, inverse functions. Right? And then if you really think about this picture and the inverse function, right? You can see this shape is more towards bending this. This shape is more towards bending this. Right? Kind of a symmetry, but opposite. Right? So that means this area and this area. Look at this. See, this area is equal to this area. So in the future means in integration, even in math methods, in integration, you need to find, they will give you integrate sine inverse x dx. Right? So that means sine inverse is this. Right? So the requirement is they ask you to find two areas. One is this area. Second area is this area. Right? So how to find it and how to clearly understand, how to put the details in, we'll learn in integration. So that's why I said calculus is heart of math, and these are peripheral things which is connecting to calculus in the future. Even in the method class, I explained to you precisely, and that applied to the specialist class as well. Right, domain range, these things we discussed already, and inverse relation. So this relation I already discussed with you. Right, I already discussed that with you. Right. So now by looking at this, you can conclude one more thing. That would be domain of sine inverse x, right? Domain of sine inverse x is equal to domain of sine inverse x, right? Yeah, same here. Domain of sine inverse sine x is equal to domain of sine x. Yeah, so which we already know from math methods as well. We'll do more questions. Right. Cos inverse function. Now, since you know how sine inverse works, it's very easy to go through this. Now, again, when you look into the y is equal to cos x, y is equal to cos x. This guy again, between -1 and 1. This guy, what is the domain? What is the domain? You can say 0 to 2 point. Okay. So now when you get the cos inverse, so that means in here, this guy is always between -1 and 1. So you can say x is this. And that is what I'm showing you here. Right. Now, when it comes to plotting cos inverse, we are starting from here, right? So this is cos inverse 1, which is this one. This is cos inverse 1 is this one. So cos graph looks like this, you know that. Cos graph looks like this. Okay. Now you might ask, we know that cos graph is like this, right? So in sine graph was like this. So sine we took from here to here. Cos graph looks like this, something like this. Why don't you take from maybe here to here, or some, why don't you take this part? So in sine you took this part, which is the left side. Why you are taking this, which is from here? The reason is 1 to 1. The reason is 1 to 1. They're 1 to 1. So that's why you are taking from here. So you, what do you call it? You restrict the domain, right? So this is cos now. Inverse of it is going to be like this. See? Look at the nice picture. Y is equal to x. Symmetry, see? Beautiful. Right? And then we'll look into the details here. Look into the details here. Now, you are starting, your domain is, so your range is 1 and your domain is 1 here. Okay. You can see this one as well, -1, and that -1 became a domain. So this is range, this is RAN, and that became domain. This is RAN, and that became domain. Okay. Then vice versa, right? So you can see the pi is here, and that's the domain, right? That's the domain, and that appears in the range in here. See? No need to remember. It's just once you know the concept, you can construct it all the time. So now, if you look into the cos inverse 1 by itself, you will see this graph. And these are the details now, right? So these two are flipped here, right? And this point over here is appearing on the y-axis. Okay, that. So that's all you have to know about cos inverse x. Now when you have y is equal to cos inverse 3x plus 2, something like this, right? So the question is about this part, which is inside. We understand inside is having this, right? So you always go to this inequality. Okay, that's what we do. Okay, good. Okay, let's finish the tan inverse function as well. So now you can see tan function looks like this between minus pi divided by 2 to pi divided by 2. And this is your tan function. So if you think about the symmetric, about y is equal to x, tan inverse looks like this. The beauty is this. So you have vertical asymptotes, right? You have vertical asymptotes for tan. Now, when it comes to tan inverse, you got horizontal asymptotes. Everything is flipped, vertical to horizontal, RAN to domain, domain to RAN, right? And then the curve looks like this, right? And that is tan inverse. Right? So the shape you understand, obviously. And why you take this shape? Why? Because 1 to 1, right? So that is math method type of. So, and this relation we already know, right? So other way around also we know, right? Other way around also we know. So now let's try to understand. When you have y is equal to tan x, right? What is the y value? Y value is real, right? All real. What is the tan? Tan, we have some restrictions, right? So because of the vertical asymptote, but if you think about a period, that would be minus pi divided by 2 to pi divided by 2, right? Right? So that means if you have y is equal to tan inverse x, this inside part, right? So that part would be a value. So you have to understand this inside part would be a value. So that means this is the value part here when you think about the reverse. So this x should be, right? X should be real, right? X should be real. Right? So if you know that part, that is enough. So this tan inverse, you have to really remember. So this is very common, tan inverse common. So this is, right, remember. Very important. With the details, pi divided by 2 and all those things, right? All those things, right? So in the future, you get questions, right? In the future, you get questions like this. Example, now you got y is equal to tan inverse x, right? So what if you get y is equal to half tan inverse x? What will happen? What will happen to the horizontal asymptotes? Right? Easy, but it should come very quick, right? So with that, if you have half tan inverse x minus 1, is there any difference, right? Inside, is there any issue with it, right? So that we need to discuss any translation and all those things we are going to discuss. So simply this is translation, right? So now how do you think? We will understand in the future. That's the whole point of this lesson. Okay. So sine inverse, cos inverse, tan inverse, basic things we have done. Okay. So I'll give you homework for this week. So you have homework for this week. This is a homework. This is a homework. This homework. This part homework. This is a homework, means all of these things. Yeah. This homework. Okay. So